my second lecture. In the previous lecture, we have studied operation on signal. Basically, we have studied time shifting, and in time shifting, there are two, that is time delay and time advance. Okay, so we have find out that alpha is less than 0 for time delay, and alpha is greater than 0 for time advance, and also we had found out that conclusion that it doesn't affect my width of my signal. Okay, now in this lecture we will study more operation on signals. Okay, so let's get started toward it. So the operation we are going to study today is time reversal. So in time reversal, we will reverse our signal basically. So if I would write the expression here, so my expression will look something like this. It is y of t is equal to x of minus t. So what I will do here is that I will take the mirror image of this signal x of t. Likewise, if there is some mirror here in front of this signal, so likewise let us consider this as a mirror. Okay, so what I will do, I will take mirror image of this signal, mirror image. Okay, so if I will draw here, it looks something like this. This is my axis t, time axis, and this is my signal y of t. Y of t is equal to x of minus t. I will draw with some other color, so it will look something like this. Since it is 3 here, so it will start from minus 3. Okay, and it will go to positive 1. This is my 0, and this is my signal x of t. Now moving toward some other operation, that is time scaling. Okay, let me write it down, time scaling. So in this operation, we are either going to compress our signal or expand our signal. So expression of y of t is represented as x of alpha of t. So what we are going to do here, we will do time compression or expansion of our signal. Okay, now if alpha is greater than 1, then it goes to time compression, and if alpha is less than 1, then it goes to time expansion of our signal. So our signal is, let us take first, that is time compression. Okay, and time compression, alpha is greater than 1. My signal x of t is something like this. This is my time axis t, this is x of t. It is from minus 1 to 3. Okay, now I will apply time compression, that is y of t is equal to x of 3t. Okay, so my signal y of t will look something like this. This is my time axis t, this is my y of t. So what I will do here is that I will divide these points by this parameter 3. Okay, so it will look something like this. So this domain will become 3 by 3 equal to 1 and minus 1 by 3. Okay, so the point here will come from minus 1 by 3 to positive 1. Okay, so this is my time compression. Now we will move toward time expansion. So in time expansion, alpha is less than 1. Now this is my signal x of t from minus 1 to 3. Okay, this is my time axis, this is my x of t. So we will take y of t is equal to x of t divided by 4. That is basically alpha here is 1 by 4. So what I have to do here is that I will multiply these points with 1 by alpha. Okay, so 3 into 1 by alpha, that is 3 into 4 equal to 12. Likewise, minus 1 into 1 by alpha, that is minus 1 into 4 equal to minus 4. So when I look my signal y of t, it will look something like this, from minus 4 toward 12. This is my time axis. This is y of t equal to x of t by 4. Okay. So this is time expansion, whereas alpha is less than 1. Okay. Now let us take a problem, that is y of t is equal to x of minus t plus 3. Okay. Now my x of t looks something like this. It is from minus 1 to 3, and this is my time axis. This is x of t. Okay. Now there are two approaches to this problem. Either I can go from right hand side, or either I can go from left hand side. Okay, so let us take our right hand side first. Okay, so what happened here is that I am looking this signal in the right hand direction, that is so what I first see here, it is a time advancement of my signal, okay, by unit 3. So x of t is, because there is a positive sign here, advance by 3. Okay, then there is a time reversal. Then it will become y of t. Okay, now we know that if a signal is advanced by 3, then we have to shift it in the left hand direction. Okay, as we have seen in our previous class. So this is my signal x of t. It is from minus 1 0 to 3. This is x of t. This is time axis t. Now advanced by 3 means what I have to do here, I had to subtract this 3 unit from here, that is 3 minus 3 equal to 0, and minus 1 minus 3 equal to minus 4. So my resultant signal after applying this operation will become something like this. It is from minus 4 to 0. This is my time axis. Now I will apply time reversal in this. Okay, so time reversal means I will apply a mirror here. Okay, so the equation will look something like this. From 0 to 4, that is y of t. Okay, it is clear to you, because there is a positive sign, so I advance my signal by 3 and then I apply the time reversal. Okay, now moving toward our second approach, that is left hand side. So in this approach, so our y of t is x of minus t plus 3. So in this approach, what you have to do, you have to take out the coefficient of t. Okay, so the uh, coefficient of t you have to take out. So this is the rule of this. Okay, so the coefficient of t in this equation is -1. So if I take out -1 here, so it will look something like this, t minus 3. Okay, so the basic operation here is, first one is time reversal, and the second one is time delay by unit 3. Okay, so if this is my signal x of t, then what I have to do is, first I have to do time reversal, then I have to do time delay of unit 3. Okay, then I will get my signal y of t is equal to x of minus t plus 3. So this is my signal x of t. It is from -3 to 1. Sorry, it is from -1 to 3. Okay, this is my time axis. This is x of t. Now I will do time reversal here. So when I apply time reversal here, so it will look something like this. -3 to 1, and this is 0. Okay, now I will apply time delay here. So it will look something like this. So in time delay by 3, that means we need to add 3 unit to these points, that is -3 and 1. Okay, so what I will do here, it is 1 plus 3 equal to 4, and here -3 plus 3 equal to 0. So my resultant signal y of t will look something like this. It is from 0 to 4. 0 to 4, and this is my t. This is my y of t. Now you will see that this signal with left hand side approach and this signal with right hand side approach, both are equal. But what I prefer is this one, left hand side, because I found it convenient. Okay. Now I will apply both time scaling and time shifting. So let us do with our left hand side approach, that is LHS. So the coefficient here is 3. Coefficient of t here is 3. Now we need to take out this coefficient. So we can write y of t as x of 3 t plus 1. Okay. So what I need to do first here, it is I need to compress my signal by 3, because alpha here is greater than 1, as we have studied in time scaling. Okay, that's why we need to compress our signal, and then after this we need to advance our signal by 1. Okay, so I can write it down as, so the first operation here is this one, the second operation is this one. Okay, so x of t, then what we need to do is compress by 3. Then what we need to do here is advance my signal by 1 unit, then we will get y of t. Okay, so my x of t looks something like this. It is from -1 to 3. This is x of t. Now I need to compress my signal by 3 units. So I will divide this and this. Let me take down some other color. That is 3 by 3, so equal to 1 and -1 by 3. Okay, so it will look something like this. -1 by 3 to 1. Okay, this is my t. Okay, now I need to advance my signal by 1. If I need to advance my signal by 1 means I need to shift my signal in left direction. So what I will do here is I will take some other color. I will subtract 1 from this. 1 minus 1 will become 0 and -1 by 3 minus 1 will become -4 by 3. Okay, so this signal will look something like this. So it is from -4 by 3 to 0. This is my y of t equal to x of 3t plus 3. Okay, now if I do it with the help of our right hand side approach, that is RHS. So in RHS what we need to do is x of 3t plus 3. If I move from this direction, first I will see here 3. So I need to advance my signal by 3. Then I see this part, this. Then I need to compress my signal by 3. First I will see this thing, 3, positive 3. So advance by 3. Then I see this part. So I need to compress my signal by 3 units. Okay, so this is our first step and this is our second step. So x of t is advance by 3, advance by 3, then compress by 3, then I will get y of t. So our x of t is from -1 to 3. This is my x of t. This is t. And I need to advance my signal by 3. That means I need to shift my signal in the left hand direction. Okay, so here it will become 3 minus 3 equal to 0 and this will become -1 minus 3 equal to -4. So it will look something like this. It is from -4 to 0 and this is my time axis. This is some intermediate signal. Okay, now I need to compress my signal by 3. Okay, so this unit will become 4 by 3 minus 4 by 3 and this will become 0 by 3 equal to 0. So it will look something like this. This is my y of t equal to x of 3t plus 3. Okay, so this signal with this approach and this approach both are same. Okay, So my both approaches are correct. Whichever you feel convenient, you can go for it. So thanks for watching this lecture, and please subscribe to my channel. And if you find some difficulty, then you can comment on my channel also. Okay, thanks, goodbye.